we are moving on to being able to calculate the volume of various cylinders in prisms and cylinders. That's what you're going to be able to do today. So volume, you need to remember, is filling something up. When I take the volume of something, let's say I have this rectangular prism, and I wanted to know, pretend that's really pretty, and I wanted to know what's the volume of it, well, you would have to fill the bottom up, right? You'd have to fill that bottom up, and then you would have to fill it up however tall it is. It is completely filling something up. The formula for volume is big BH. Notice the area for a triangle is B times H over 2. There's a difference. There's a little b and a big B. In a math world, there's a big difference between those two. Big B is the area of the base. So it's not the base, it's the area of the base. Big B is area of the base. Little b is just the base. Okay? Okay, and then some students, especially with geometry units, they're not sure, well, what do you want the base to be? A base can be anything. A base can truly be anything as long as it's got a parallel face. So I'm not going to do any math yet on this first example. I'm just going to help you visualize. Some of you will look at the front of this as the base. You'll be like, oh, the base is 6 by 2. You could, but then you have to understand that the height connects the two bases. Bases are whatever are parallel to each other on planes. Okay? So I have this front, then the back is the other base. Some of you look at it and think, hey, this side is my base. I can envision tipping it up, and then this would be my bottom square. And you could, as long as you know the height connects the two parallel sides. So it doesn't matter what you pick. What matters is that it has a parallel face to it. Okay. So I always start. This is that standard that you can justify the volume formula. Volume is big BH. Big B is the area of the base. I'm going to go ahead and pick the side as my area of the base because I have the two numbers. So the area of my base is 4 times 2, and the height connects the two faces. So my height is 6. 48 cubic, because you're three-dimensional, cubic centimeters. And you didn't have to. If you would have went 6 times 2, that would have worked too. 6 times 2 and then times it by 4, you would get the same thing, as long as it's parallel. The next one, I have a triangular prism. So my triangular prism, it does matter which one my base is, because there's only two faces that are parallel to each other. There's this triangle and the other triangle. Nothing else has a parallel sides. So that's how I know that it does matter what my base is. So big BH, I always start out with that, big BH. The base is my triangle, so it's got the area of a triangle is little b, which is 4, times the height of the triangle, not the height of the base, height of the triangle. 1.5 divided by 2. And then the height is the height of the prism. It connects the two parallel bases. So times that by 6, and you just punch that in. 4 times 1.5, 4 times 1.5 divided by 2 times 6 is 18. 18 cubic meters. Okay? How many sides could I use for a base on this next one? 1 or 2, I guess. You have one one pair of bays because there's only one set that are parallel to each other. This face is parallel to that face. Notice that this rectangle that's on like that top intersects with the other rectangle, so there's no way that they are parallel. So, big BH, let's justify the formula and analyze big B. Lots of triangle, so it's going to be the base of the triangle, 9, times the height of the triangle, 4, divided by 2, that's my big B. And the H connects the two parallel faces. So what's connecting my bases is at 8.1. And then you punch that into your calculator and you get 9 times 4 divided by 2 times 8.1 equals 145.8 cubic centimeters. And this one is always kids' favorite because they have to do less. But I can still, a lot of you are like, oh, just multiply the numbers. Absolutely, go for it. Multiply all the numbers. But there is that foundation is you take the area of the base. Notice it can be anything here because you have, every side has something parallel to it. So you could choose anything to be the base. I'm going to choose 7 and 4. So area of my base is 7 times 4, and my height connects the two bases, 10. 280 cubic centimeters. Okay, so that is finding normal volume. Now we're going to construct the volume of a cylinder. So turn to your volume of a cylinder page. Whoops, right here. And now we're going to analyze and justify the volume for a cylinder. So here's my formula. Volume is big BH. Looking at a cylinder, you could draw one if you wanted a visual. Looking at the cylinder, remember the definition of a base is that they're parallel to each other. It has a parallel side. So what is the shape of a cylinder base? Is a circle. So a base is a circle. What is the formula for the area of a circle? Yep, so area of the base is pi r squared, so that's our big B. So our final formula is big B, which we know is pi r squared, and then you times it by however tall it is. So area of no, not area, what the goodness. The volume of a cylinder is pi r squared times h, which means let me fill up the bottom of this cylinder, and then I'm going to keep filling the bottom up however tall it is. So it's going to be the bottom circle by however tall it is. Okay. Notice that my second one looks different than yours. I want you to take a minute and modify your second one. All right, so now I'm going to find the volume of this first tall cylinder. I can envision it personally being like an Arnold Palmer can. It looks kind of tall and skinnier. So I know that it's big BH. The base is a circle, so the area of the circle is pi r squared. My r is 4, so it's going to be 4 squared times 3.14 times the height of my cylinder, 6. Then you go ahead and punch that into your calculating device, and you get 16 times 3.14 times 6, 301.44 cubic centimeters is the volume of that cylinder. The next one, what I envisioned myself, I'm envisioning an Intex temporary ultra-frame pool. It's about that time of year people are thinking about putting pools up and stuff. A very popular pool dimension is 16 by 48, which means the diameter of the pool is 16 feet and it's 48 inches tall, which is really 4 feet. Okay. All right, so if I want to find the volume of this, well, I got big BH. Notice I always start with what I know, big BH. The base is a circle, so I know that it's pi r squared times the height, which is 4. Notice I didn't write what the r squared was because I don't know r. I only know diameter right now. So if my diameter is 16, what is my radius? 8. Yep, my radius is 8. So now I can do it. 8 squared times 3.14 times 4. And that gives you 803.84 cubic feet to fill up that pool, if it was a pool. Okay, one more thing I want to do today, and that's working backwards. So turn to your working backwards side. There we go. We're kind of all over the place with this pattern. So we can work backwards. Now that we know the area or the formula for the volume of prisms and cylinders, we can work backwards if we're given the formula or the volume. Okay, so let's say that the volume of this particular rectangular prism is 200 cubic inches. What would the length of the base be? So this must be, I'm looking for this measurement. So I know that for volume I typically multiply everything, so working backwards would be to divide. So I would start with the number 200, and instead of multiplying everything, I divide. So I'm going to divide by the 10, I get rid of that 10, and then I'm going to divide by the 4, I get rid of that 4, and I will, whatever I'm left with will be that missing dimension. 200 divided by 10 divided by 4 is 5. And this would be 5 inches. You can always double check your work if you're a little unsure of working backwards. So you should be able to go 5 times 4, times it by 10, it should give you 200. 5 times 4 is 20, 20 times 10, 200. So it definitely worked out. Okay, the next one. If the volume is 552.64 cubic centimeters, what is the height of the cylinder? So I want to know what's the height of that cylinder. So I like to just go ahead and write my formula down so I can keep track of working backwards. So pi r squared times the height, which I don't really know. So now I got an r and an x in there. What the goodness. But don't worry, because I know my r. I know my r, so I'll be able to fill that in. What is 4 squared? 16. So 16 can go there. So this is going to be 4 squared times pi times x. And now I have everything I need. I don't really need to keep writing the formula. I just need to know pi r squared. That's all I need to know. So now you can start with your volume, 552.64, and instead of timesing by everything, I will divide by 16. That will get rid of that 4 squared. And then I got to get rid of the pi. How do I get rid of that pi? Divide by 3.14. So I get 552.64 divided by 16 divided by 3.14, and that's 11. So the height is 11 centimeters. And one more working backwards. So if the volume of this triangular prism is 2400, what's the height of the triangle? I'm looking for the height of the triangle. Well, here's what I know. Big BH, which is little b, times the height, divided by 2, times the height of the prism, 60. And then you start working backwards. I also know little b is 8, so I can go ahead and fill that 8 where that little B is, and you can start working